word atom, it means indivisible, something that cannot be further divided. And a number of Indian philosophers, they propose that particles of matter, atoms, normally exist in a combined form, and various combination of particles gives us various kinds of matter. The combined form of this atom, it is called as molecule. Antonio Lavoisier in 1774 gave the law of conservation of mass. This is one of the laws of chemical combination, and these experimental laws, which were formulated by these scientists after performing a number of experiments, therefore led to the idea of atoms being the smallest unit of matter. Now let us discuss the different laws of chemical combination. A number of laws of chemical combination were given. Law of conservation of mass, law of constant proportion, and law of multiple proportion. These three laws were given by different scientists after performing a number of experiments. Law of multiple proportion is not there in your syllabus, so we'll discuss it in higher class. In this video, we'll discuss the first law of chemical combination, that is law of conservation of mass. Law of conservation of mass, which was formulated by Lavoisier in 1774, states that mass can neither be created nor destroyed in a chemical reaction. I would just like to add to it that it can be converted to other forms in a chemical reaction. The law of conservation of mass means that in a chemical reaction, the total mass of the product is equal to the total mass of the reactant. There is no change in mass during a chemical reaction. When we had discussed the statement of law of conservation of mass, we said it cannot be created, it cannot be destroyed, but it can be converted. Let us look at this example. In this example, a log of 30 kg is burnt in air of 1 kg, and it produces ash of 20 kg and smoke of 3 kg. The number of reactant was 31 kg in total, and the product as well was 31 kg. Only the form got converted. The wood got converted into ash and smoke when it combined with oxygen. Therefore, we did not create, we did not destroy, but only converted to other forms. When element A combines with element B, it produces a third compound, that is compound C. In this case, mass is neither created nor destroyed in ordinary chemical and physical changes. Now let us understand this law with the help of a small video. This law, as I already said, is given by Antonio Lavoisier in 1774. When scientists in the 18th century noticed that if they carried out chemical reaction in a closed container, then there was no change in mass. According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. Summarizing it, we can also say that the substance which combine together or react in a chemical reaction, that is the reactant, and the new substance which formed or that is produced, called the products, the masses of the reactant and the product, they remain same. as you can see on your screen, that the total mass of the reactant is equal to the total mass of the product. Let us take an example. Let us take the reactant in the form of hydrogen and oxygen. Hydrogen and the oxygen, they are the reactants. First, we calculate the total mass of these reactant, and when they undergo a chemical combination, that is when hydrogen reacts with oxygen, it gives certain product. The product here is in the form of water. So the mass of hydrogen and oxygen must be equal to the mass of the product, that is water. Now let us weigh them and find the masses of hydrogen and oxygen, and therefore compare it with the mass of water. Hydrogen, as we know, the mass is 2 gram and the mass of oxygen is 16 gram. So the total mass here is 18 grams. What about water? Since water also contains 2 hydrogen and 1 oxygen, that is 2 grams of hydrogen plus 16 gram of oxygen will also give 18 gram. As stated by the law of conservation of mass, the mass of the reactant is equal to the mass of the product. The mass is neither created nor destroyed. Let us take another example of carbon plus oxygen. When carbon combines with oxygen, that is the reactant, it gives the product carbon dioxide. Let us find the masses of all the reactant. What is the mass of carbon? The mass of carbon is 12 grams and the mass of one oxygen atom is 16 gram. So the mass of 2 oxygen atom will be 32 gram. So the total mass here on the reactant side, it comes out to be 44 grams. Let us see the product. The product formed is carbon dioxide, and the total mass of carbon dioxide with 1 carbon atom and 2 oxygen atom also is 44 grams. This states again that the total mass of the reactant is equal to the total mass of the product. They are neither created nor destroyed, rather only converts into a new form, that is carbon dioxide. Let us verify this law of conservation of mass with the help of an experiment as well. This experiment is given in your textbooks. In this case, we take a clean conical flask which is fitted with a rubber cork and a small test tube with a thread tied to its neck. All these things are weighed together on a sensitive balance to find the initial mass of the apparatus. In the experiment, we take some barium chloride, as you can see, solution in a conical flask. We add some copper sulfate carefully into the small test tube and lower it in the conical flask by holding from the free end of the thread tied to its neck. We also fix a rubber cork in the mouth of the flask so that it holds the thread firmly. The mouth of the small test tube should remain above the liquid level in the flask so that the reactants do not get mixed at this stage. We find the mass of the apparatus along with the reactant by weighing on the balance, and we subtract with the initial mass of the apparatus and say we'll get the mass of the reactant and let the mass of the reactant be X. Now remove the rubber cork and allow the copper sulfate present in the test tube to mix with the barium chloride solution. Now the barium chloride, it reacts with the copper sulfate and therefore forms We again find the mass of the apparatus along with the product by weighing on a balance. If we subtract the initial mass of the apparatus from this mass, we get the mass of the product. Say the mass of the product is Y. If the mass of the product Y is equal to the mass of the reactant X, then this experiment verifies the law of conservation of mass. In the next video, we'll discuss the law of constant proportion and also try to solve a few questions based on this law of conservation of mass. Review through your lecture. Take care. Stay safe.